Hello, hi everyone. Welcome to the Stone the Brand. This is our Shiva sir. Today we are going to discuss about light reflection and refraction. Light reflection and refraction. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. So in this topic completely we'll discuss about reflection of light. Reflection of light we will discuss. Okay, so reflection of light, loss of reflection, angle of incidence, angle of reflection, regular reflection, irregular reflection. Okay, so all those points we'll discuss. So let's start this session. So you can see, so regular reflection, so reflection of light. Okay, reflection of light. So start with reflection of light. Reflection of light. So here you can see the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. So I am taking this plane surface. This is a plane surface. So incident ray, reflected ray, and this one is the normal line. Incident ray, reflected ray, normal line. Okay. So angle between incident ray and normal line is called angle of incidence. So this incident ray, this one is the reflected ray, and this one is the normal. Okay. So this is the undeviated line. The angle between incident ray normal line is called angle of incidence. Angle between reflected ray and angle of reflection. Okay, and you can see the angle between reflected ray and deviated line is called angle of deviation. The bouncing back of the light from the reflecting surface is called reflection of light. So incident ray, reflected ray, normal line. Angle between incident ray normal line is called angle of incidence. Angle between reflected ray and reflected ray normal line is called angle of deviation. Angle between reflected ray and deviated line is called angle of deviation. So now, we'll discuss about loss of reflection. Loss of reflection. Loss of reflection. Loss of reflection. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Okay, incident ray, reflected ray, normal line lies on the same plane. Point number 1. Incident ray, reflected ray, normal line lies on the same plane. Point number 2. Angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. These are the two laws of reflection. Once again, so we will discuss about reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay, so the angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Okay, so let's discuss regular reflection and irregular reflection. Regular reflection and irregular reflection. Regular, so you can see here, so this is a plane mirror, okay, so incident light rays are parallel, These are the incident light rays. These incident light rays are parallel. Then reflector light rays are also parallel to each other. That type of reflection is called regular reflection. Incident light rays are parallel, then reflector light rays are also parallel to each other. That type of reflection is called regular reflection. Coming to irregular reflection. So here you can see these are incident light rays are parallel, right? These light rays are parallel to each other. Okay, so these light rays, incident light rays are parallel. So once okay, so now you can observe these are incident light rays. Incident light rays. Incident light rays are parallel, then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. Okay, so you can see these are the incident beam, incident parallel beam, incident parallel beam, and this is the reflected parallel beam, reflected parallel beam. Okay, so incident light rays are parallel, then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. So coming to irregular reflection, incident light rays are parallel, but reflector light rays are not parallel to each other. So that type of reflection is called irregular reflection. So here you can see this irregular reflection. So incident light rays are parallel, but reflector light rays are not parallel to each other. So observe here. Okay, you can check here. So incident beam is parallel. Incident parallel beam. Or incident light rays are parallel, but reflector light rays are not parallel to each other. Okay, so this is about regular reflection and irregular reflection. Regular reflection takes place on smooth surface, whereas irregular reflection takes place on rough surface. Okay, regular reflection takes place on smooth surface, irregular reflection takes place on rough surface. So regular, irregular completed. Next one we will discuss about object and image. Object and image. So let's start object and image. Okay, object and image. Now we will discuss about object and image. So here, so light rays are coming from the source. After reflection, those light rays are meeting here. You can observe. So this is the real image, and this is a virtual object. Virtual object and real image. Virtual object and real image. Okay. So next one here, one more I'm taking like this. So you can observe these two diagrams. If you observe these two diagrams, so here you can see, so light rays are coming from source. After reflection, those light rays are meeting at one point. Those light rays are meeting at one point. This is a real image. Real image. So now you can see, if you are extending this incident light rays, extended incident light rays are meeting at one point. So their virtual object is formed. Virtual object. And here you can see, so from this point light rays are coming after reflection. After reflection, those light rays are moving away from it. So if you are extending these light rays, extended light rays are meeting at one point. Okay, so I hope it is very clear. So object is real, image is virtual. Object is real, image is virtual. Okay, I'll draw this one. So you can check this one. This is the table. Object and image. Object is real, image is virtual. Object is virtual, image is real. So I hope it is very clear. So this is about object and image. So next one we will discuss about nature of the image formed by the plane mirror, or characteristics of the image formed by the plane mirror. Nature of the image formed by the plane mirror, or characteristics of the image formed by the plane mirror. Let's start. So nature of the image formed by the plane mirror. So here you can see, so this is the object. Object is here. So light I am taking like this. So normally if the light ray is passing along the normal line, it retraces its original path. Normally if the light ray is passing along the normal line, it retraces its original path. So here you can observe, here you can see, so if you are taking like this, if the light ray is passing along the normal line, it retraces its original path. It retraces its original path. So I am taking here, if the light ray is passing along this normal line, okay, and here also you can see, after reflection those light rays are moving away from it. And here also if you are taking like this, so after reflection, okay, so if you are extending this is the object AB, and this is a plane mirror, right? This is a plane mirror. This is a plane mirror. Okay. So now you can check once here. So if you are extending these light rays and extending these light rays, so if you are extending these light rays and extending this light ray, image will form. So AB, A dash and B dash, AB, A dash and B, A dash and B dash. Okay, so here you can see this is the object. This is the object and image. Object and image. So object is real, image is virtual. Object is virtual, image is real. Object is real, image is virtual. Object is virtual, image is real. Right? So point number 1. So object is real, image is virtual. Object is virtual, image is real. So point number 2, object distance. So what is the object distance? The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Okay. So here this object, the distance between object to mirror is called object distance. Distance between mirror to image is called image distance. Okay, in the plane mirror, object distance is equal to image distance. And here you can see, so this is object distance. Okay, U, and this one is the V. So object distance is equal to image distance. Height of the object is equal to height of the image. And coming to the fourth one, so magnification of the plane mirror is +1. Magnification of the plane mirror is +1. And also it shows lateral inversion. What is lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Lateral inversion. I hope it is very clear. Right? Yes. So any other points? If you have any doubts, just you can let me know. So I'll discuss. Any other points related to this one? So okay, so that's enough. This is the object and image. Okay, so nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. So now we'll discuss about spherical mirrors. So the mirror which are in the form of curved surface is called spherical mirror. There are two types of spherical mirrors, concave mirror and convex mirror. There are two types of spherical mirrors, concave and convex mirror. Concave and convex mirror, right? So let's start. So here you can see this is the spherical mirror. So depending, it is a part of the sphere. So we are taking the small portion. Okay. So if you are taking the small portion, so one is concave mirror, another one is convex mirror. Reflection takes place. So I'm taking this a concave mirror. So whenever light rays are incident on it, after reflection, the light rays are meeting at one point. Okay, so here is the, so whenever light rays are incident on it, after reflection, those light rays are meeting. So those light rays are moving towards the principal axis. That's why concave mirror is in converging nature. So if you are taking one more, so here you can see like this. So when light rays are incidenting on it, after reflection, those light rays are moving away from it. So you can observe. So after reflection, these light rays are moving away from the principal axis. So concave mirror is in converging nature, convex mirror is in diverging nature. Concave mirror is in converging, convex mirror is in diverging nature. Okay, so now we'll discuss about image formation. So ray rules of concave mirror and convex mirror. Ray rules of concave mirror and convex mirror. Okay, so better. Anyway, topics are already explained many times. So let's go to the problem solving. I'll write the question. Let's start the problem. Okay, so I'll give one more question. So let me know the answer to this question. So here you can see, so what is the value of n21 and n12? So here you have to observe one thing. That is, so you have to consider this value. Check once here. So n21 and n21. So whatever the value comes, that you have to write in the numerator. So I'm writing here n2 by n1 into n1 by n2. So then if you cancel these two, you will get 1. So answer is 1. Is it correct? Okay, so let's go to the next question. So related to refract index only we'll do it. One more question. So that is a question. So try to solve it. good, Shivani. Correct answer. 10 power 8. Nice. So refractive index equal to speed of light in air by speed of light in glass. So already refractive index is given 1.5 and the speed of light in vacuum is 3 into 10 power 8 meter per second. So we have to find out speed of light in glass. So refractive index equal to, normal formula is, so refractive index equal to N equal to C by V. Here already C is, we know, 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second. So we know that one. Now, so we have to find out V value. So N value already given. N is how much? 1.5. So here is 1.5. So 1.5. So substitute the value 1.5 equal to, so 3 into 10 power 8 by V. So V equal to 3 into 10 power 8 by 1.5. So that is nothing but 3 by 2 we can write. 3 into 10 power 8 by 3 by 2. So if it is goes up, so 3 into 2 into 10 power 8 by 3 get cancelled. Then answer is 2 into 10 power 8 meter per second. That is the answer. You can check once. If you like the content, if you like my explanation, if you like the channel, so do like, share and subscribe. Thank you so much for joining and Shanik, thank you so much for attending. So one more question. So one more example. Thank you. So try, will go to the next question. When light enters, from A to glass, the angles of incidence The angles of incidence and refraction in air and glass are 45 degrees and 30 degrees respectively. Find the refractive index of glass. Refractive index of glass. So given that sin 45 1 by root 2 sin 30 1 by 2. Try to solve this question. Hi Nachket, how are you? Okay, do well. So answer is you'll get root 2 value. Yes, 1.4. Correct. So just substitute the values, that's enough. So here you can see they're asking, so when light enters from air to glass, the angle of incidence and angle of reflection are, angle of incidence is nothing but sine of angle of incidence, angle of reflection are nothing but angle of sine of angle of refraction angle. So find the refractive index of glass. So they're asking you to find out refractive index of glass. Refractive index of glass. Okay, so let's start. So the formula is mu g equal to sin I by sin r. Sin I by sin r. Sin r. So what is sine angle? So sine of angle of incidence is 45. Here already they given values. You can directly take. Correct only, right? Snell's law. So sine of angle of incident is nothing but 45 by sine 30. So sine 45 how much? Sine 45 how much? That is 1 by root 2 already given here, and you can write 1 by 2. Then you'll get 1 by root 2 into 2 by 1. That is 1 by root 2 into root 2 into root 2. So this get cancelled, then root 2 value. That is 1.4. Refract index, right? So that is refract index. So I hope it is this answer. Just check once. If you have any concern, let me know. Is it correct? Next. So next we'll discuss one more question. So next one, mirrors will do. Mirrors. Morning also, from morning onwards we are doing the same. Problems practice, right? We wish to, okay, so I'm asking one question, try to answer to the question. We wish to obtain an erect, we wish to obtain an erect image of an object using a concave mirror. We wish to obtain an object using a concave mirror of focal length is 15 centimeter. What should be the range of distance of the object from the mirror? So what is the nature of the image? So is the image larger or smaller than the object? Draw the ray diagram to show the image formation in this case. So which one, which position you are thinking? Which position can you get to know? Can you know this one? So object position must be between P and F. So we have to use concave mirror. We have to use concave mirror. We wish to obtain an erect image of an object using a concave mirror of focal length 15 centimeter. What should be the range of distance of the object from the mirror? What is the nature of the image? So is the image larger or smaller than the object? Draw the ray diagram to show the image formation in this case. So actually, object must be placed between P and F. Object must be placed between P and F. Then only we'll get virtual erect and enlarged image. Virtual erect and enlarged image. Okay. So in this case, we have to place the object between P and F. Object between P and F. Right. Okay. So name the type of mirror used in the following situations. Name the type of mirror used in the following situation. First one is, so headlights of the car, side and rear view mirror of a vehicle, solar furnace. So headlights of the car, where we'll use, what type of mirror we'll use? Concave mirror, convex mirror? Headlights, concave mirror. Side or rear view mirror of the vehicles, convex. And solar furnace, what type of mirror we are using in solar furnace? Solar furnace, we are using concave mirror. Okay. So next one more. So uses of mirror. Uses of mirrors. Okay, let me know what is your doubt. Yeah, of course. Practice makes teacher, student, everyone will be perfect. Yes, we are working on it. Just 1 minute. So, so So I'll ask, so one more question. Calculate 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 the focal length calculate the focal length and nature of spherical mirror and nature of spherical mirror. Spherical mirror which forms a 1/3 times magnified virtual image of an object placed 18 centimeter in front of it. Okay, so try to solve this question. So here calculate the focal length and the nature of the spherical mirror. So let me know the answer. Try to solve it. So V is given. So we have to find out the focal length. Focal length is positive for which mirror? Convex or concave? So negative for concave, positive for convex. So you have to understand that one. Okay, check once here. Easy. So here 1/3 times. Calculate the nature and of spherical mirror which forms 1/3 of virtual image they mention. Virtual image means magnification is +1. So m equal to solution m equal to +3 plus 1/3 and object distance already given -18. So object distance anyway. So minus. So we know magnification equal to minus v by u. Okay, so that is nothing but plus 1 by 3. So you can minus v by u, how much? Minus 18 equal to 1 by 3. Yes or no? Right? So now you can cancel these two. Can cancel. So I'm cancelling these two. Then you will get v equal to, so 18 by 3. That is 6 centimeter. Now 1 by f equal to 1 by v plus 1 by u. So 1 by f we have to find out f. 1 by f equal to v how much? 1 by 6 plus object distance is minus 18. 1 by minus 18. So 1 by f equal to 1 by 6 minus 1 by 18. Then if you take LCM, 1 by f equal to 18, 3 minus 1, so f equal to 2 by 9, sorry, f equal to 2 by 18, f equal to 2 by 18, then f equal to 18 by 2, that is 9 centimeter, f equal to 9 centimeter. So this is the answer, positive sign you got, so that's why. So mirror is what is the mirror? What is the nature of the mirror? Nature of the mirror is virtual erect. What is the nature of the mirror? Virtual diverging. Okay. Yeah, very good. Nachiket, correct answer. So your doubt will solve.